Hi guys, my name is Peter Sitokwa Jr., mathematics instructor at the University of Liberia and your mathematics tutor. So in this video, I'm going to be discussing finding the derivative of functions, particularly trigonometric functions, and we're going to do the last trigonometric function, which is cot of x. And in the previous video, we did the derivative of sine, cosine, tangent, cosecant, and secant. So we want to now do cot. So we're going to find the derivative of cot using the first principle of derivative and not the methods of derivative. The first principle of derivative. So there is the first principle of derivative along with these useful properties. So we know that cot is equal to cos of x all over sine of x, right? So with that now, we can now find both f of x and f of x plus h. So our f of x is the original function, always, like I told you. And the f of x plus h now is derived from the f of x. So in place of this x, we take this x from there and put x plus h. So on the right hand side of the equation, we do the same. Cos of this x, now we put x plus h. And we also do the same down here by saying sine of x plus h. So in the problem now, we can replace the limit of f of x plus h minus f of x all over h, as h is approaching 0. This is just equal to the limit. So this f of x plus h now is this one, which is cos of x plus h all over sine of x plus h minus cos of x all over sine of x, all divided by h. So f prime of x is just equal to the limit. So we can simplify this expression. So the LCD will just be sine of x times, so it's this times this one. So it's sine of x times this one. So it's sine of x times sine of x plus h. So sine of x plus h goes into this. So it means that this will cancel. You'll be left with sine of x. So it's sine of x times this one. So we got sine of x times cos of x plus h. Minus sine of x goes into this one. Sine of x will cancel. You'll be left with sine of x plus h. So it's sine of x plus h times cos. So it's cos of x times sine of x plus h, as h now approaching 0. So we can change this sign to multiplication and reciprocate. We get 1 over h. So now we are to find the expansion for cos of x plus h and sine of x plus h. So that will be sine of x, cos of x plus h now is just equal to cos of x, cos of h, minus sine of x, sine of h. This will be the expansion for this one. Minus this one as well, cos of x, and then we expand this. So we give us sine of x, cos of h, plus sine of h, cos of x. Then this h now we can factor it under, let's say, right beside this one. So it's h sine of x plus h. as h now approaches 0. So we got f prime of x to be equal to the limit. So we can multiply. So it's sine of x, cos of x, cos of h, minus sine square x. Okay, which one of them is this? Okay, so this is h, not x and x. So this is sine square x and then sine of h, minus the same thing here. We have cos of h, cos of x, sine of x, and then cos of h, minus cos square x, and then sine of h, all divided by h, sine of x, sine of x plus h, as h approaches 0. So within the denominator, we are not too concerned about expanding the expressions in the denominator. Our focus is to simplify the numerator so that we can arrive at, some of these properties. Okay, so now we think of how we can do factoring by grouping. But now look here. If you keenly look here, you see that we have our sine of x, yeah, cos of x, yeah, cos of h, yeah. So this and this cancel. Opposite signs. And then, so we have f prime of x is equal to the limit now of negative sine square x sine h minus cos square x sine of h, all over h sine of x plus h, as h now approaches 0. F prime of x. So we can factor out negative and also factor out sine of h. So what we'll be left with? Sine square x plus cos square x, all over h times sine of x plus h, as h approaches 0. So from the Pythagorean theorem, we know that sine square x plus cos square x is equals to 1 from the Pythagorean theorem. So from that property, we can further reduce this expression to minus. Now this negative can even come behind this limit. So you have sine of h all over h. Sine of h over h equals to 1 as h approaches 0. And then this one now you will have like 1. And then in here now will just be sine of x times sine of x plus h. So we take the limit of this one. It gave us minus 1 right there. Minus 1 now. And then times 1 all over sine of x plus 0 as h approaches 0. So therefore we will have, we almost done. Therefore we will have negative 1 all over sine of x times sine of, now this is already 0, so it's sine of x as well. So f prime of x will be equal to minus 1 all over sine of x all square. So minus, what is 1 over sine? 1 over sine is cosecant of x. So since this whole thing is square, now it becomes cosecant squared of x. Therefore, f prime of x is just equal to negative cosecant square of x. So this is the last problem for the derivative of the trigonometric functions using the first principle of derivative. So thanks ever so much for watching. See you next class. Thank you.